When I first met John von Neumann, I had the peculiar feeling that I was not observing a man think. I was observing a phenomenon. You know how sometimes you watch a lightning storm from far away, and you see the flash before you hear the thunder, and for a split second the sky rearranges itself into something electric and alien. That was what it felt like to watch Johnny's mind at work. Now I've known many brilliant people. I've worked with geniuses. At Los Alamos Laboratory during the war, brilliance was practically the entry ticket. And I'm not easily impressed. I like to take things apart, poke at them, see if the gears grind. But with Johnny, there was no grinding. There was no visible effort. You'd pose a problem, something messy, tangled in equations, crawling with assumptions. And before you'd even finished sharpening your pencil, he'd lean back slightly, eyes half, focus somewhere beyond the ceiling, and deliver the answer. Not a guess, not an approximation, the answer. I remember thinking, this is not calculation as I understand it. This is something else. You see, when most of us think, we move step by step, like a train traveling from station to station. First assumption, then deduction, then correction. If we're careful, we check the timetable, logic, to make sure we haven't derailed. But Johnny, it was as if he saw the entire railway system at once. Every station, every track, every possible collision, already mapped. Let me give you a picture. Imagine you're standing on a platform watching a train rush by. You measure its speed. Simple enough. Now imagine you're inside the train, measuring a beam of light bouncing between two mirrors. A little clock made of photons. If the train moves, the light's path tilts, stretches. Time itself adjusts. That insight took years of wrestling for some of the greatest minds in physics. You've got to break your intuition. You've got to accept that simultaneity is slippery, that space and time are not rigid scaffolding but flexible fabric. For most of us, accepting that feels like learning to walk again. But Johnny, he didn't struggle with intuition breaking. He seemed to have no allegiance to intuition in the first place. I once watched him absorb a complicated description of a nonlinear differential system. Unstable, chaotic looking stuff. The kind of problem where you expect pages of scratch work. Instead, he translated it instantly into a higher, dimensional geometric picture, as if the equations were merely shadows of something he could already see. It was like watching someone rotate a four-dimensional object in their hands. And here's the strange part, he did it conversationally, casually, with humor. Now, I've always believed that understanding comes from being able to explain something simply. If you can't reduce it, you don't really get it. I pride myself on that. But Johnny didn't reduce complexity, he encompassed it. He didn't simplify the world. He accepted its full density all at once. There's a difference. When I worked on quantum electrodynamics, I developed diagrams, little pictures, to tame the infinities, to organize the chaos, lines and vertices, a bookkeeping device for the subatomic dance. They were my way of making the invisible manageable, step by step. Johnny didn't need diagrams. He once derived in his head transformations that would take me several pages to verify. I tested him. Of course I did. I'd change a parameter slightly, twist the boundary condition, see if the machine would stall. It never stalled. It recalculated instantly. And I began to wonder something unsettling. What if his brain wasn't operating sequentially at all? What if, instead of computing through time, it accessed structure outside of time? Now don't misunderstand me. I'm not invoking mysticism. I'm a practical man. I like things you can test. But the experience of observing him forced a question. What is thinking, really? We assume thought is linear because we experience it as a flow, one idea after another, like frames in a film. But in physics, we learn something profound. What appears sequential in one frame can be simultaneous in another. Two lightning strikes that seem simultaneous on the embankment are not simultaneous on the train. Maybe cognition has frames too. Maybe most of us ride inside the train, watching thoughts pass by one at a time. And maybe Johnny was standing on the embankment, seeing the whole event laid out in spacetime. There were moments when he would interrupt someone mid-explanation, not out of rudeness, but because he had already leapt to the end point. He wasn't impatient. He was ahead, way ahead, as if the future of the argument was already present to him. Once, during a discussion about computing machines. These early, room-sized beasts. He described architectures that seemed absurdly ambitious, stored programs, self-modifying instructions, logical structures layered upon logical structures. To him, it was obvious that machines would mirror formal logic, the way clocks mirror periodic motion. To the rest of us, it sounded like science fiction. But he wasn't predicting. He was extrapolating from a structure he already saw complete. There's a moment in physics when you first understand that the laws don't care about your comfort. Light doesn't slow down because you expect it to. Time doesn't tick uniformly because your watch says so. Reality is under no obligation to match human intuition. Watching Johnny think felt like witnessing a mind that had already accepted that, not just in physics, but in thought itself. He didn't rely on mental crutches. He didn't seem to need intermediate scaffolding. It was as if the axioms lived closer to the surface for him, and that's when the unsettling idea crept in. Perhaps what we call intelligence is not just speed, not just memory, not just pattern recognition, but the dimensionality of representation. Most of us think in 3 dimensions and time. We picture, we narrate, we simulate. But what if his internal representation space had more axes? What if problems that looked tangled to us were straight lines in his geometry? That would explain the calm. Because when you see curvature from above, you don't get lost in it. I don't mean he was infallible. Nobody is. But there was an economy to his reasoning that felt non-human isn't the right word, but beyond the standard model of cognition. I remember leaving one conversation with him and feeling a strange mixture of exhilaration and discomfort. Exhilaration because I had glimpsed what the human brain might be capable of. Discomfort because I had glimpsed the gap. In quantum mechanics, the observer plays a peculiar role. Measurement changes the system. But sometimes I felt that observing Johnny changed me instead. It forced me to expand my idea of what a mind could be. And standing there, in that desert laboratory with chalk dust in the air and equations half erased on blackboards, I had the uncanny sensation that I wasn't just collaborating with a brilliant mathematician. I was witnessing an evolutionary edge. And the question that began forming, quietly, persistently, was this: if one brain can operate that way, what does that say about the limits we casually assign to human understanding? There's a moment in physics when you realize the world is not built the way your senses report it. You look at a solid table and think it's continuous, firm, real, and then you learn it's mostly empty space, a dance of probabilities and fields. The first time that truly sinks in, something inside you shifts. Watching John von Neumann think produced a similar shift in me. It wasn't just that he was fast. Speed is mechanical. You can imagine gears spinning quicker. This was different. It was as if the gears were unnecessary. Let me try to explain what I mean. Suppose we're analyzing a complex physical system. Say, particles scattering in quantum electrodynamics. Most of us approach it like climbers scaling a mountain. We pick a route. We test footholds. We correct mistakes. Sometimes we slip. Eventually, if we're careful, we reach the summit and look down at the path we took. Johnny seemed to begin at the summit. I would watch him listen to a problem. Really listen, head tilted slightly, and then I could almost see a geometric transformation happening behind his eyes. Not arithmetic, not algebra, geometry. As though he immediately translated every statement into a higher level structure. It reminded me of spacetime diagrams. When you first encounter relativity, motion seems complicated. 2 observers disagree about lengths, about times, about simultaneity. It's messy until you draw the diagram. Then you see that all the confusion dissolves into rotations in 4-dimensional spacetime. What seemed contradictory becomes simple geometry. Johnny thought in spacetime, even when the subject wasn't physics. Arguments were geometric objects to him. Logical systems were landscapes. Computations were trajectories. And I began to suspect something radical, maybe ordinary thought is a projection, like a 3-dimensional object casting a 2-dimensional shadow. Most of us operate in the shadow. Sequential reasoning, step-by-step inference. But Johnny appeared to operate in the full-dimensional object itself. When we worked around the early electronic computers, those room-filling contraptions humming with vacuum tubes, most people saw tools. calculators that could automate arithmetic. Johnny saw architecture. He described stored programs, conditional branching, symbolic manipulation, recursive structures. He saw machines that could, in principle, model any formal system. He wasn't dazzled by the hardware. He saw the abstraction behind it. It was like watching someone look at a clock and immediately conceive not just of gears, but of periodicity itself, of time as an abstract parameter independent of its mechanical representation. Now here's where it becomes unsettling. In quantum mechanics, we talk about Hilbert space, this enormous, abstract space where states live. A particle isn't just here or there. It exists as a vector in a vast mathematical structure. When we calculate, we manipulate that vector. But we don't see Hilbert space. We project it down into measurable quantities. What if Johnny's mind was more comfortable in Hilbert space than in ordinary sensory reality? What if the rest of us are constantly translating abstract structure into pictures we can tolerate? Little mental cartoons. While he stayed in the structure itself, I once challenged him on a complicated combinatorial problem. It involved a cascade of possibilities branching exponentially. The sort of thing that makes your head spin because the number of cases explodes. He listened quietly. Then he said, almost absent-mindedly, but the symmetry reduces the independent cases. And he described a mapping that collapsed the entire mess into something manageable. He didn't fight the combinatorial explosion. He saw the symmetry instantly. And symmetry, that's the key. In physics, symmetry is a kind of divine whisper. Conservation laws emerge from it. Structure emerges from it. When you recognize symmetry, complexity falls away like excess baggage. For most of us, spotting symmetry is work. For Johnny, it seemed automatic. Imagine you're riding a train at nearly the speed of light. Outside, the world compresses in the direction of motion. Time dilates. Clocks tick differently. To someone on the platform, your journey is long and drawn out. To you, it's brief. Both descriptions are correct within their frames. Now imagine two minds tackling the same problem. In my frame, the solution unfolds over time. Trial, error, revision. In his frame, the solution is already compressed. The path I experience as long and sequential appears to him as short and simultaneous. The difference isn't intelligence in the crude sense. It's the frame of reference of cognition. I started to wonder whether the architecture of thought itself has invariants, quantities that remain constant across minds, and transformations, like Lorentz transformations, that relate different cognitive frames. When I struggled through pages of algebra and Johnny skipped directly to the result, maybe we weren't disagreeing about truth. Maybe we were occupying different cognitive velocities. And yet, there was warmth in him. Humor. He laughed easily. He enjoyed food, conversation, absurdity. So it wasn't cold calculation. It wasn't machine-like detachment. That's important. Because if it had felt mechanical, I could have dismissed it as mere computational horsepower. But it didn't feel mechanical. It felt organic, but at a different scale. There were evenings when discussions drifted from mathematics into philosophy. Questions about determinism, about randomness, about whether the universe is fundamentally discrete or continuous. Most of us approach these like explorers in fog, feeling our way forward. Johnny spoke as if the fog were thinner for him. Not gone, thinner. He could hold multiple models in his head simultaneously without confusion. Deterministic frameworks alongside probabilistic ones. Continuous equations alongside discrete automata. He didn't feel threatened by contradiction, he organized it. And here's the most fascinating part. He was comfortable with abstraction in a way that made reality itself seem like a special case. You and I, we start from experience. We see clocks tick, we see trains move, we see light flash. Then we abstract laws. But Johnny seemed to start from formal systems and treat physical reality as an instantiation of them, as though the universe were one example among many possible logical structures. That perspective changes how you relate to the world. It's like realizing that the map isn't just describing the territory. Sometimes the territory conforms to the map. Watching him, I felt something similar to what I felt when I first accepted that time is not absolute, a kind of vertigo. Because if thought can exist at that level of abstraction naturally, then perhaps consciousness itself is less about narrative and more about structure. Maybe what we call understanding is just alignment between internal structure and external structure. And Johnny's internal structure was extraordinarily aligned. But alignment raises a deeper question. If a brain can operate like that, if it can manipulate formal systems almost as effortlessly as breathing, then what is the true boundary between human cognition and machine computation? Are we carbon-based computers limited by noise and emotion? Or is there something else, some emergent property, that allows a mind to leap dimensions of abstraction? Standing in front of a blackboard with him, chalk dust floating like tiny galaxies in the air, I sometimes felt as though I was observing not just a brilliant colleague, but an early glimpse of the future. A future where intelligence might not be tied to biological limits at all. And that thought, that quiet, persistent thought, was both thrilling and deeply unsettling. There is a temptation, when you encounter a mind like John von Neumann, to mythologize it, to say here is something superhuman, something alien. But I've always distrusted mystification. The universe is already strange enough without us adding in sense and poetry where analysis will do. And yet, analysis only takes you so far. Because what unsettled me was not that Johnny could calculate faster. It was that he seemed to inhabit abstraction the way the rest of us inhabit air. Let me bring you somewhere familiar. Imagine again that train platform. A train rushes by. You're standing still watching. Inside the train, someone shines a beam of light from the floor to the ceiling. To them, the light goes straight up and down. To you, on the platform, it traces a diagonal path. Same event, different geometry. Now suppose there's a third observer, one who sees not the two-dimensional projections, not even the three-dimensional scene, but the entire four-dimensional spacetime track of that photon at once. The whole history of its motion laid out as a single object. For that observer, there is no before and after in the way we experience it. There is only structure. That's what watching Johnny felt like. He didn't seem to experience the before and after of reasoning the way I did. He perceived the argument as a complete space-time object. The assumptions, the transformations, the conclusion, all coexisting in a higher logical manifold. When I developed my diagrams for particle interactions, I was trying to give myself and others a way to see processes at once, a way to compress time into structure. It was a trick, a useful trick. Johnny didn't need tricks. He once described computation not merely as arithmetic automation, but as symbolic evolution. Programs stored in memory, instructions modifying instructions, logical systems capable of self-reference. At the time, those ideas were radical. Machines were calculators. Period. But he saw beyond the hardware to the abstract architecture. The idea that any formal system could, in principle, be embodied in a machine. You can feel the tremor in that idea. Because if thought is formal structure, and formal structure can be mechanized, then what are we? Carbon implementations of logic. That question doesn't diminish humanity, but it reframes it. In quantum mechanics, the observer cannot be separated cleanly from the observed. Measurement entangles them. Perhaps intelligence is similar. Perhaps a mind is not a static object, but a dynamic interaction between structure and environment, between formal rules and lived experience. Johnny was profoundly formal, but he was not detached from reality. He was fascinated by weather patterns, by economics, by biology. He saw computation everywhere, not as metaphor, but as principle. Clouds evolving like cellular automata, markets fluctuating like stochastic processes, brains firing like networks of logical gates. The world, to him, was a vast computation unfolding in time. Now here's where it becomes almost metaphysical. In relativity, we learned that there is no universal present. What exists is a four-dimensional block, space-time, where past and future are equally real within the geometry. Our sensation of flow is a feature of our consciousness, not of the fundamental equations. If intelligence operates at a higher level of abstraction, perhaps what we call thinking is simply our low-resolution experience of a deeper structural alignment. Johnny seemed to experience that alignment directly. I remember one evening, walking outside after a long day of discussion. The desert sky above was enormous, stars sharp and cold. I thought about how light from those stars had traveled for thousands of years before reaching my eyes. We see the past as present because of finite light speed. Our perception is always delayed. Maybe cognition is similar. Maybe most of us are seeing the past light cone of a solution, tracing it backward step by step. But perhaps some minds can perceive the entire geometric object at once, independent of its temporal unfolding. That doesn't make them supernatural. It makes them differently oriented in cognitive spacetime. And yet, there was something distinctly human about Johnny. He enjoyed jokes. He loved rich food. He could be impatient, even mischievous. He was not a cold theorem-proving automaton. Which means whatever that cognitive dimensionality was, it coexisted with laughter and appetite and ego. That coexistence is the real mystery. Because if intelligence can scale upward, into higher abstraction, greater structural compression, without losing humanity, then perhaps the limits we assume are self-imposed. We like to imagine a clear boundary between human and machine, between natural and artificial. But the more I watch Johnny conceptualize computation, the more I sensed that boundary dissolving. Not because machines would become human, but because we would understand ourselves as systems, dynamic, logical, embodied systems. The shock was not that he was machine-like. The shock was that machine, like reasoning, could feel so alive. In physics, every time we expand our conceptual framework, from Newton to relativity, from classical mechanics to quantum theory, we discover that reality is larger than our intuitions. Perhaps the same is true of intelligence. Perhaps what I witnessed in him was not an anomaly, but an extreme point in a vast possibility space of minds. If you imagine intelligence as a landscape, most of us cluster in a valley. Similar heuristics, similar limitations. Johnny stood on a high ridge. From there, patterns invisible to us were obvious. Connections that required labor for us were simple lines of sight for him. That ridge felt, at first, non-human. But maybe that was just my perspective from the valley. And here is the final thought that stayed with me, long after the chalkboards were erased and the war was over. If a single brain can expand so far into abstraction, then the potential of human understanding is not fixed. It is elastic. It can stretch into domains that feel alien at first, into dimensions of thought that seem mechanical, geometric, almost inhuman, and yet remain grounded in curiosity and play. Because that's what defined Johnny in the end. Not cold brilliance, but delight. Delight in structure. Delight in logic. Delight in seeing farther than yesterday. And perhaps that is the most human trait of all. The universe does not yield its secrets easily, but occasionally you meet someone who seems to converse with its structure directly. Watching such a mind is like watching light bend around a massive star, space-time curving, possibilities warping, horizons shifting. It doesn't mean the laws are broken. It means you've glimpsed their full depth. And once you've seen that, you can never again believe that the boundaries of understanding are where they appear to be.